So the moral of the story is, just because you have spot exposure doesn't actually mean you have any flexibility from it.
A big challenge or a point of critique on renewable energies is usually the lack of continuity and flexibility. PV only generates power during the day and windmills only when it's windy. However, on the other hand, the digitalization, new storage technologies and intelligence in the grid create more flexibility on the consumer side, thus providing the potential to even this out. So what's the status quo when it comes to flexibility in the energy grid? Who is coordinating the individual grid stakeholders on the demand side? What is the development in the coming years? And what does an energy cloud platform has to do with it? Brace yourself for an episode full of insights and stay tuned to learn, for example, the difference between implicit demand-side flexibility or explicit demand-side flexibility. Welcome to the SmartEn podcast, a podcast for and with the creators of the new energy world. A world in which energy will be renewable, decentralized and digital, bringing together electricity, heat and mobility. Let us show you how we will get there and who will get us there. As the expert of the episode, I'm very happy to welcome Dr. Paul Troughton. Paul has worked in demand response for more than a decade already with experience in various markets all around the world. Currently, he's working as the Senior Director of Regulatory Affairs for Enel X, basically the biggest demand-side aggregator in the world. Furthermore, he represents Enel X at SmartEn, which is Europe's business association integrating specifically the consumer-driven solutions into the clean energy transition. Great to have you on the podcast, Paul.
Thank you, Zach. It's good to be here.
In my preparation, when I checked the landing page of Enel X, I stumbled upon this term I've never heard before, Paul. Energy cloud platform. What does that mean for you?
When you have a lot of demand-side resources and different technologies on different customer sites, you need to orchestrate them efficiently. And an energy cloud platform is a scalable solution for doing that. One thing that sets us apart as a large-scale aggregator is we've made big investments in the technology to be scalable, and that is a good term for what we've built to do that.
Now I have even more questions, Paul, but maybe let's have a go at them one by one, and let's start at the beginning. What is flexibility in the context of the energy transition, and is it maybe even the key for a renewable power system?
I think the answer to the second question is yes, but yes, let's talk about what flexibility is. It's about what you need to keep production and consumption in balance on all timescales, and there's several aspects to that. It might be helpful to go back to the sort of Stone Age of power systems and how people traditionally thought of how you plan your power system. So you look at customer demand as kind of an exogenous input. It's something that happens, and your job is to build a power system which can cope with that customer demand. There wasn't really much effort put into trying to control the customer demand. It's just meet it. And to do that, you look at the statistics of how often is how much demand required. There's a tool called a load duration curve where you look at the for each hour of the year, what the total demand will be. If you sort things in descending order of total demand, you end up with a curve that at one end has a peak, that's the few hours of the highest demand, and then it tends to sort of tail off into a flat area where there's lots of very normal hours where demand is very similar. And then your generation fleet that you build, and traditionally this would be what your central authority decides to build, would be a mix of different technologies. The base load would be coal or nuclear or combined cycle gas turbines. The peaking end would be cheaper technologies to build but more expensive to run, like open cycle gas turbines, maybe even oil-fired plants. And in between you have mid-merit. So there, the flexibility is coming from everything apart from the baseload plants. Now, that's not how things work anymore. We've moved from having central planning to having markets, but they're still doing the same kind of thing. But what gets really interesting is when you add renewables, variable renewables in particular, so wind and solar. You want to use as much of that output as you can. For obvious environmental reasons, it's zero carbon energy. You want to use as much of it as possible. There's no point using something else when that's available. But also the economic reasons. typically there's almost zero marginal cost to getting a megawatt hour out of a wind turbine or a solar plant after you've built it. So you should try to use as much as you can. What that then means is that the job of the whole of the rest of the power system is to fill in the mismatches between the renewable output and the demand. And the term for this is the residual demand. So that's demand minus renewable output. And you can think of this as having a low duration curve, just as I talked about before. As you add more renewables, these curves get different. The residual demand low duration curve gets more and more extreme. And so the generation fleet you'd build to serve that residual low duration curve is different. It's smaller overall. You don't need so much other capacity, but the utilization factors are very different. You might have no base load at all, but you need a lot more of the flexible plants.
Thanks. That was a really brilliant explanation of a rather complex topic. So if we focus on the demand and consumer side of things, what role does the consumer play in regards to flexibility?
Well, as I said earlier, flexibility is about managing the balance of supply and demand. Rather than adjusting the supply, you can adjust the demand. It's equally effective. So instead of increasing generation, you can reduce demand or vice versa. So if you can find a customer that can reduce their consumption or adjust their consumption, they can provide flexibility just the same as a generator would. Sometimes actually they're better. They can provide very fast response that you need for some ancillary services, so frequency control. And in terms of what customers, it's anything you can flex. If you look at our portfolio at the moment, it's almost all industrial and commercial customers, but that's just because those tend to be bigger sites. So for the effort you put in enabling a customer to participate, you get a larger reward that you can share with the customer. On the smaller the site, the harder the economics becomes.
So when you say industrial or commercial customer, what does an ideal or even a typical customer look like?
The ideal customer for providing demand-side flexibility is a cold storage unit, so big frozen warehouse, because the chillers need to run quite a lot of the time, but not all the time. And you can turn them off, because they're well insulated, for several hours. So you can shift the consumption of that site in either direction by several hours. It's a very flexible resource. It doesn't cost them anything much to do it. It's just the inconvenience of setting up the control systems to ensure that they can. But more generally, any kind of industrial process can generally be shut down. Any production plant, a factory that has multiple stages of production, typically not all of them run with a 24-hour full output. You can shut down parts of them without interrupting the output.
Now that sounds like a brilliant way of just using intelligence and connectivity and building on existing infrastructure, on existing customer use cases. At the same time, there's amazing advances in the storage technology. How relevant is storage in regards to flexibility?
Well, storage is great. It can do everything you want. It's very fast. It's very controllable. It's better than what we can do with customers in most cases. So it's really not surprising that system operators all want to have a lot more storage on their systems, and it's getting cheaper rapidly year over year. But I would say there is a fundamental difference between demand-side flexibility, the kind of things I was talking about from factories and you could also get from homes, and anything else, whether that's a battery or a traditional power station. With the battery or the traditional power station, you're going out and building something, investing capital in order to build an asset that you will use to provide these services. And you're primarily doing it in order to provide the services. Whereas the difference with demand-side flexibility is we're not going and building assets. We're going and finding assets that are already there and then being intelligent about how we use them. So we're extracting flexibility from something that already exists. Now, that's a very different prospect in terms of the economics. We don't have this big capital cost. We have a little bit in control systems and so on. But it means that we should be a great deal more cost effective than any dedicated resource. And that's not just in terms of financial costs, it's also the economic cost. There's no embodied energy in a big battery or a big generator because we're not actually having to build anything new. A nice study recently by the Lawrence Berkeley National Laboratory looking at the demand response potential in California, they took a different approach where they thought of demand-side flexibility as a load-shifting resource. So rather than an alternative to a peaker, it was an alternative to a battery. But looking forwards to 2030 in California, where they already have a lot of renewables, they're adding a load more, they found the need for about 10 gigawatt hours of storage to help balance the renewable generation demand mismatch in the state. But their study showed that only half of that did it actually make sense to build battery storage for. The other half, 5 gigawatt hours, would be provided more cost effectively by demand-side flexibility.
That's a really cool example, Paul. Now, I guess if you compare storage with demand-side flexibility, the advantage of storage is that it's really in your hands. You can build as much as you want and you can run it. Whereas if you focus on demand-side flexibility, you obviously depend on all your customers. Is it a challenge to get them all on board and be part of that system? But before you answer to that, it's time for a quick shout out to our partner for this episode, which is BNE. Like no other, the Association of Energy Market Innovators, or in German Bundesverband Neue Energiewirtschaft, stands for Market-Based Flexibility Solutions. The aim is to coordinate demand and supply of electricity in times of volatile power generation based on renewables and to ensure a reliable power supply. The BNE, together with its members, are engaged in the advancement of the regulatory framework. So back to you, Paul. We heard that demand-side flexibility can be, for example, much more cost-effective than using storage. So what's the biggest challenge in getting these stakeholders on board?
The real challenge is persuading customers that they can do this. It's often seemed to be assumed by policymakers that all you need to do is make price signals available and then customers will become flexible. In reality, when you go and talk to a customer, there are exceptions. There are some who are incredibly sophisticated, but most customers, you go and say, we've got this great idea, we're going to give you money in exchange for being a little flexible in how you consume energy. And their immediate response is, we can't do that. We have to keep on making widgets. We can't interrupt what we're doing. That would be disastrous for our business. And the challenge for us is to get beyond that initial refusal and say, there's lots of other people in your industry who have done this, and this is how they've done it. Let us work with you. Let's figure out what we can make flexible. So that's the big hurdle, and that's where much of our effort goes. Then having figured out what flexibility they have and quantified that, it's then figure out where are the best value uses of it, which markets can we offer it into? Is it useful to the transmission system operator or the distribution system operator? Is it useful as capacity? Can it be used for more frequent shifting? Can it be used very, very fast for sub-second frequency response, which is particularly important in small power systems with lots of renewables and hence low inertia?
All right. So that means the biggest challenge is not a technological one, but more like a people, culture, and mindset challenge. Usually, anything in the energy transition also at some point comes down to the regulators playing along or not playing along. So what regulatory levers would have to be put in place to advance demand-side flexibility and to better implement it in the electricity market design so it actually becomes a business model worthwhile pursuing?
It's interesting. I mean, often when you think about sort of what your ask is of regulators and of governments and policymakers, in many industries, it's essentially what subsidies can you give us? Whereas the nice thing about demand-side flexibility is that it's so intrinsically cost-effective that that's not what we need. All we need is to be given the ability to compete. If we have a reasonably level playing field, then the cost effectiveness of this demand side flexibility should mean that it becomes very lucrative for the customer and also for us and also for all other consumers because we're providing the service at lower cost than it could otherwise be provided.
When you say level playing field, what would that mean practically?
There has been an approach called technology neutrality, so the Clean Energy Package does a lot of good things, including putting an obligation on system operators to procure services in a technology neutral way. But technology neutrality doesn't necessarily go far enough. If you have designed your product and your market around the needs and capabilities of a gas-fired generator, which is very easily done because those are the ones who have been providing the services for decades, then saying, yes, you can compete, but only if you have exactly the same characteristics as a gas-fired generator doesn't give a level playing field. So the challenge now, I think, is to rethink product design and move beyond technology neutrality into technology inclusiveness, where you proactively simplify the design of your products in order to make it possible for any plausible technology to compete in providing the service.
Technology inclusiveness. Thanks. Yet another term in my vocabulary. So, and by the way, I love that you say you do not need subsidies, but simply just a level playing field. That's very cool. And that obviously speaks to the maturity of your approach. So in order to join the discussion on the topic, what other terminology do I need to be aware of? And is the approach that you described so far the only way to go about it, or are there other approaches I need to be aware of?
Well, what I've described so far is often called explicit demand-side flexibility. That's where we're using these demand-side resources to compete directly with generators to provide the same services. And the idea is that you have the market arranged so that we can be paid in just the same way as the generator for providing those services. There is another approach for at least for energy balancing, which is implicit demand-side flexibility. So that's where rather than paying the customer for providing a service, you just expose the customer to time-varying prices and expect them to change their behavior in order to minimize their cost of buying energy. And that's very appealing to many economists and policymakers. It's how a simple market should work. It has a lot less complexity. It makes perfect sense for kind of everyday decisions. I don't think it's so useful for when you're dealing with extreme situations. So an example of implicit demand response not really working as everyone hoped is what happened recently in Texas with their blizzards. So there was massive disruption there, mostly because of gas plants not being weatherized or there being too much demand for gas. But the effect was the spot price rose to an extraordinarily high level. It was in the thousands of dollars per megawatt hour. It turns out there were a lot of customers who were exposed to the spot price, which is exactly what your implicit demand response supporting economist would want. These people are buying at the real-time energy price. They have all of the incentives that you need to have efficient balancing. But it turns out that many of them were not in any way set up to respond, to flex their consumption as a result of the prices. And now they're just complaining that they're being charged these massive bills for a few days of power, and they're going bankrupt and so on. So the moral of the story is, just because you have spot exposure doesn't actually mean you have any flexibility from it.
While you talked about the implicit demand-side flexibility, I had to think back to one of our previous episodes where one of our guests was Professor Gülich from the Mobility to Grid Institute in Berlin. He talked about one of the pilot projects where their partner runs a big fleet of electric buses in Berlin, and they just really profit from the fact that they can charge them off-peak, which saves them a lot of money. So is that the kind of use case for implicit demand-side flexibility that you envision when you think of the sector coupling in regards to mobility?
Absolutely. And we do manage an electric bus fleet in Santiago, and I think in much the same lines. But also, you can also use electric vehicle chargers in an explicit way. So in California, we have about 6,000 smart electric vehicle chargers that customers have bought from Amazon, and they've signed up with us in order to get a rebate on the price. And they've installed them themselves because they wanted the chargers. They've connected them to their Wi-Fi, and they use our app because they want the convenience. But we actually have control over them with the customer's agreement, such that we can offer that flexibility into the day ahead and the real-time energy market. And it looks like a 70 megawatt hour virtual battery, but it's actually just a whole bunch of residential EV chargers.
Residential EV chargers forming a 70 megawatt virtual battery obviously is a textbook example for mobility to grid. But just to challenge you once again towards the end of the podcast, it is also complex, tying all these different stakeholders in. So do we really need this approach at the bottom line? Is it just not much simpler to solve the flexibility on the operator side, on the generator side, or in other ways?
It's not necessary. You absolutely could do it on the generation side. But you'd have to build a lot of generation and a lot of network infrastructure to cope with it. So you'd have to overbuild your renewable generation and build a lot of peakers and flexible generation plants to balance for them. It's doable, but that would be crazily expensive. So the reason to involve the demand side is that it allows you to do the energy transition faster and at much lower cost.
I think that's really a great insight to end with, because hearing about an approach that is not only resource effective, works with renewable energy, and is also on top of that more cost effective, of course, is a best case scenario here in the context of the SmartEn podcast. Thanks a lot for joining me in this episode, Paul.
Oh, thank you for having me. It's been a pleasure.
Well, really, the pleasure has been mine. I finally really understand the significance of the individual stakeholders on the consumer side in the future energy grid. Whether that stakeholder is a private person such as me with their EV, or whether that is an industrial and commercial use case, as you highlighted, for example, a warehouse just running their refrigerators at a different time than they used to. And it's also been really interesting to understand the difference between implicit and explicit demand side flexibility. So whether that is either driven by price and a fleet operator being able to charge off-peak, or whether that is due to an aggregator such as Enel X just tapping into our existing resources and really managing them. Stay tuned for more episodes of the SmartEn podcast. If you found this to be very insightful as well and you want more information on the flexibility in the context of the energy transition, then visit EM Power Europe, the international exhibition for energy management and integrated energy solutions, as well as the associated EM Power conference. More information on both can be found at em-power.eu.